According to a travel website, workers in a certain country lead the world in vacation days, averaging 16.32 days per year. The following data show the number of paid vacation days for a random sample of 20 workers from this country. Complete parts A through C below. So here we're going to look at this. Construct a 99% confidence interval to estimate the average number of paid vacation days for workers from this country. And so I need a lower limit and an upper limit. And here I have data. I don't have the summary statistics, but I actually have the data. I could type all this into StatCrunch, or if I choose this little icon right here, I can open it in StatCrunch. So it'll open up a StatCrunch window. And in this window, we will actually have the data entered. Let me look at this. And I think if I can actually move it. There we go. So here, to find the confidence interval, I will press Stat, go to T statistics. We do not know the population standard deviation, sigma. We're going to compute S from our sample data. It's a one sample, and we have the actual data. So in this case, our data is in the variable 1 column. I'm going to compute a confidence interval, 99% confidence. And here I've got some things that I could choose. I'm going to go ahead and plot the confidence interval. And I'm also going to look at the normal quantile plot. Press compute. And so here in my table, I have the lower limit and the upper limit of my confidence interval. So rounded to 2 decimal places, we'll enter these. So I've got 14.51 is the lower limit. And the upper limit would be 32.39. And so in part B, they asked this question: do the results from the sample validate the website's findings? So the website claimed that they averaged 16.32 days per year. And so here are our choices. Since the population mean, 16.32, is contained within the 99% confidence interval, it can be said with 99% confidence that the sample validates the website's findings. B, since the population mean, 16.32, is not contained within the 99% confidence interval. Well, that would be false because 16.32 is actually contained in it. So it's going to be A or C. They begin with the truth that 16.32 is actually contained in the interval. And so C, how does it differ? Since the population means 16.32 is contained within the 99% confidence interval, it can be said with 99% confidence that the sample does not validate. Well, they claim it's 16.32 days per year. My confidence interval does contain 16.32 days, so that is a possibility. The interval does not rule it out. I'm not sure if it validates it with a great deal of strength, but I cannot rule it out. If they say that it's 16.32, my interval doesn't conflict with that. So we'll choose A. And so part C asks, what assumptions need to be made about this population? Well, in this case, how many days did we sample? There were only, degrees of freedom is 19. There's only 20 days that were sampled. So since this sample size is fairly small, I need to assume that the population of all days, the vacation days during the year, is normally distributed. So the only assumption here needed is that the population distribution is approximately normal. Now, if I go over here, I did plot the quantile plot. And so what I have here are a bunch of points that line up pretty close to being in a straight line. They're a little above and a little bit below. And so it's not unreasonable, although I do see something of a flow of a pattern here that might not necessarily be linear, but close enough for now. Check our answer. All right.